Picture this. You're sitting down with a big bowl of your absolute favorite fruit. Let's say perfectly ripe, sweet mangoes. That first mango? Absolutely incredible. The second one? Still pretty great. But what actually happens when you just keep eating until you literally cannot take another bite? Well, welcome to The Explainer. Today, we're taking this incredibly relatable everyday experience and looking at it through a fascinating mathematical lens. Because in economics, this scenario is governed by a very precise, hidden dance between two core concepts, and we're going to unpack exactly how that dance works.
Here is our roadmap for The Explainer. We'll quickly introduce the utility concept, dive into the data grid, check out the twin graph alignment, break down the three phases, and finally, hit the point of satiety.
All right, first up, introducing utility concept. Before we hit the numbers, we just need to get our vocabulary straight. So, our first player here is total utility, or TU. You can just think of this as your cumulative score. It's the sum total of all the satisfaction you've derived from consuming all the units of something over a given time. If you eat 3 mangoes, your total utility is simply the combined happiness you got from mango 1 plus mango 2 plus mango 3. It's the big picture.
But marginal utility, or MU, that's the real driver here. Marginal utility is strictly the additional satisfaction you get from consuming just one extra unit. It only cares about that very last mango you ate. Mathematically, it's just the difference between your current total utility and the total utility you had exactly 1 unit ago.
Moving right along to the data grid, let's actually put some real numbers to this mango eating scenario.
Okay, look at this schedule, tracking our consumption from 0 all the way to 6 mangoes. At 0 mangoes, obviously 0 utility. But row 1, boom, you eat that first mango, and both total and marginal utility start at exactly 10 utils. It's incredibly satisfying. Now you eat a second mango. Your total utility climbs to 17. Why? Because the marginal utility, the specific joy from just that second mango, was 7. 10 plus 7 equals 17. As we push to 3 and 4 mangoes, TU climbs to 21, then 22. But look at what the MU column is doing. That additional joy is steadily dropping. It goes from 10, down to 7, down to 4, and just one single util for the 4th mango. Then, at the 5th mango, marginal utility hits a wall at exactly 0, leaving total utility completely flat at 22. And if you force down a 6th mango, MU plunges to -3 and actually drags your total utility down to 19.
So the huge takeaway here is that marginal utility and total utility are tethered together like two dancers. Marginal utility leads the steps, dictating exactly how high total utility can go. As long as MU is bringing something positive to the table, TU keeps growing. But the second MU falters, TU responds instantly.
Which brings us to the twin graph alignment. Let's actually visualize this mathematical tether.
This alignment is honestly brilliant. You've got the total utility curve tracking up on the top graph, mathematically locked to the downward sloping marginal utility curve on the bottom graph. And notice how they are perfectly stacked, sharing the exact same x-axis for the number of mangoes. Because they're aligned like this, you can trace a straight vertical line up from any mango on the bottom graph and instantly see exactly how that specific marginal utility is driving the total utility curve above it.
Let's break this visual down into the 3 phases of consumer equilibrium.
There are 3 distinct phases happening in these graphs, and they are entirely controlled by marginal utility. Phase 1, MU is falling but positive, which makes TU climb at a diminishing rate. Phase 2, MU drops to exactly 0, forcing TU to hit its flat maximum peak. And finally, Phase 3, MU goes negative, actively pulling TU downward. Let's look closer at Phase 1.
So Phase 1 is happening during those first 4 mangoes. As you keep eating, your intense desire naturally cools off. That's why the MU curve slopes steadily downward from 10 utils to 1 util. But, and this is absolutely crucial, even though that additional satisfaction is shrinking, it's still a positive number. Because MU is positive, that total utility mountain on the top graph just keeps growing, climbing from 10 to 17, 21, and up to 22. The climb just gets a little less steep with every bite.
Now for Phase 2, the point of satiety.
This is it, the absolute climax of our data model. When you eat that 5th mango, marginal utility hits exactly 0 on the x-axis. You gain literally no extra satisfaction from it. And because nothing new is being added, the total utility curve on the top graph hits its absolute maximum, flat peak at 22 utils. This perfectly vertical alignment, where MU is 0 and TU is maxed out, is known as the point of satiety. You are completely, perfectly done.
But what if you just ignore that feeling?
If you push right past satiety and force down that 6 mango, you enter phase 3. The marginal utility curve actually plunges below the x-axis into negative territory, hitting -3. It's practically a penalty to eat it at this point. And because our driver is now negative, it mathematically drags the total utility curve down right along with it, pulling your total cumulative happiness down from 22 to 19 utils.
So this entire sequence, from that first amazing bite to the ultimate decline, is an unbending economic law. Marginal utility always leads and total utility follows. Think about a recent binge-watching session, or maybe a massive meal you had. Can you pinpoint your own point of satiety? And more importantly, when did your own marginal utility take a dive below the x-axis and drag your overall experience down with it? Understanding this little mathematical dance can honestly help you make way smarter, more satisfying choices every single day. Thanks for joining me on this explainer, and keep an eye out for the economics happening in your own daily decisions.